Hello, this is Mr. Kinyanola, and I'm going to help you figure out the tangent value in the unit circle. Before we figure out what tangent is, we need to do some review on its brother and sister or cousin or relative, whatever, aunt, uncle, which is the sine. First one is sine and cosine. So cosine is or opposite over hypotenuse. Cosine is or the adjacent over the hypotenuse, the adjacent side over the hypotenuse. And tangent is toa. So tangent is equal to the opposite over the adjacent. Okay, now let's focus our attention to the sine and the cosine in a unit circle. So if you watched my previous video, we came up to a conclusion, but right before that final conclusion, we figured that the hypotenuse is equal to the radius, and the radius in a unit circle is always what? Say 1. 1. Yes, you got it. It's 1. That's why it's called the unit circle. It's just 1 unit. So here's a unit circle. Here's a hypotenuse. If this was a triangle, and that hypotenuse is 1. 1, 1, 1, 1. So let's set this equal to, let's substitute that hypotenuse, since we know it's 1, to 1. Okay, so I hope you guys are following along. Hope you guys are writing this in your notebooks. If not, press pause and put this in your notebooks. Same thing over here with cosine, adjacent over 1, because the hypotenuse is 1. Okay, and let's simplify this some more. So opposite over 1 is just opposite, and adjacent over 1 is just the adjacent. Yeah. Okay, so let's see if we can substitute a few things over here for the tangent. If the tangent is equal to the opposite over adjacent, and let's look at this. And what is this opposite equal? Sine. So we can substitute the opposite with sine over, and adjacent, what is adjacent equal? Cosine. So tangent is equal to sine over cosine. And we can still find another identity for this. So if from yesterday's video, we came up to a final conclusion. Sine is equal to the opposite, and the opposite is always which coordinates or which value? The y coordinate. Yes, the y coordinates, and the cosine is always equal to the adjacent, and the adjacent is always what? The x coordinate. Yes, I heard you, the x coordinate. So let's substitute sine, because sine is always the y value or the y coordinate. We can write y coordinate over, let's write out the entire thing, over the x value or the x coordinate. Let's put a box over here. This is very important. So just remember, tangent is equal to the opposite over adjacent, which is equal to the sine over the cosine, which is equal to y over x. Put this in your notebooks. Make a power card on this. Put tangent on the front. Put all this on the back. And when you put this in your notebooks, highlight it like crazy. This will help you, especially in Algebra 2 and math analysis and calculus in future and in life. So, yes, tangent is equal to the y over the x. So let me show you some examples. There's some arithmetic, some math involved, some algebra involved. It's not as easy as just the y for sine, x for cosine. It's y over x. So y divided by x. So here is, let's find an example for you. Okay, so question asks, what is the tangent, and let's focus on this one, what is the tangent of 30 degrees? And remember, tangent is the y over the x. Let's refer to our unit circle. 30 degrees, it's the y, which is 1/2 divided by radical 3 over 2. So let's write 1/2 over radical 3 over 2. Oh man, a fraction over another fraction. Look at all these fractions. It's like inception fraction. Okay, so remember a fraction, this line right here is really a division sign. So it's 1/2 divided by radical 3 over 2. So I'm just writing it horizontally from vertically. And then we're going to convert this to a multiplication problem. So 1/2 times. And remember, when you change this into multiplication, you use a reciprocal of that second fraction. So 2 over radical 3. Okay, so then let's look at this. If we multiply this out, before we multiply, what can we cancel out? We can cancel these 2's, and we're left with 1 over radical 3. But here's the thing. In math, you can't have a radical in the denominator, or it's not preferred to have a radical in the denominator. So this is how you get rid of the radical. If you remember from Algebra 1, good. If you don't, then here's how you get rid of this radical. So we're going to multiply this fraction. We're not going to change the value. We're going to multiply this fraction by 1, but a different kind of 1. We're going to multiply by radical 3 over radical 3. If you look at it, radical 3 divided by radical 3 is just 1. So we're multiplying this by 1, so we're not changing the value. We just want to get rid of this radical in the denominator. So let's multiply this out. 1 times radical 3 is radical 3. Radical 3 times radical 3 is radical 9, or the square root of 9. And if we simplify this, our final answer would be radical 3 over 3. So there's our final answer. So by multiplying this by this 1, this weird looking 1, we were able to get rid of the radical in the denominator. So this is still the same value as this. It's just the radical has disappeared or has been taken away from the denominator. So there is our final answer. So tangent, so we wrote y over x, okay, and we made that horizontal like that. We made it to a multiplication problem and used a reciprocal, multiplied, and we got this number right here. We didn't want a radical in the denominator, so we multiplied it by this 1 right here to get rid of the radical, to get our final answer as radical 3 over 3. All right, so let's do another example. Okay, so 60 degrees. 60 degrees, let's look at our unit circle. Remember, it's y over x. So for 60 degrees, it is radical 3 over 2. Okay, and I'm going to just put the division sign right there, symbol over there, and divided by the x, which is 1/2. Then I'm going to change this to a multiplication problem. Radical 3 divided by 2 times 2 over 1. Okay, and these 2's cancel out, and we're left with radical 3 over 1, and which is just radical 3. Right, you can have a radical 3 in the numerator, so that's fine. So there is your final answer. We don't have to do any converting or changing like in the previous problem. So there's the tangent of 60. Okay, let's do another problem. Okay, so tangent of 135 degrees. Again, it is y over x, the sine over the cosine. So 135 degrees, let's figure this out. So the y value is radical, let's write it over here. It's radical 2 over 2 divided by negative radical 2 over 2. So let's change this into multiplication. So radical 2 over 2 times negative 2 over radical 2. This may look a little daunting, but it's not that bad because these 2's cancel out, the radical 2's cancel out, and we're just left with a negative. So our final answer is negative 1. Hey, that wasn't too bad. Okay, and our final problem, tangent of 270 degrees. So, whoa, 270 degrees is this one, and it's the y over the x. This is a good one because the y value is negative 1 over the x value, which is 0. And can you have a 0 in the denominator? Can you have something over nothing? No, you can't. So your final answer would be undefined, because you can't have a 0 in the denominator. You could have a 0 in the numerator, but not in the denominator. So your final answer is undefined. So that's how you find the tangent values in a unit circle. And the same process, you can use the same process if they didn't give you degrees, but they gave you radians. So if they asked for the tangent of pi over 3, just again, take the y over the x. So that's how you find the tangent in a unit circle. All right, have a great day.